like CFTR. And one way is just through the GPCR adenylyl cyclase pathway that we talked about last week. Okay. Second way, though, that is a little bit more direct, is some cells can just use this G protein directly to bind to ion channels and cause them to open. Basically, skip all the adenylyl cyclase, cyclic AMP, protein kinase stuff, and just have the G protein directly bind to and activate the ion channel. Basically, the G protein itself is the one activating our final response, the ion channel. Make sense? Oh, but the easiest way, and the way we're going to talk about today, to skip all of that crap, no receptor, no G protein, no nothing, and just open up this channel with some kind of chemical. So what if the primary messenger, the primary signal, could just bind directly to this channel and get it to open without going through all that signaling pathway? That'd be pretty sweet. So that'd be super fast. We don't have to bind to receptor, we don't have to make any other proteins. We just directly go to the final effect, final source, which is opening up that ion channel. Yeah?
And for the second one, in which instances does that occur?
Sometimes it can occur in the similar pathways that we've seen right now, where you can activate either through a G protein or you can go through all the pathway. But this GPCR stuff is really signaling throughout the entire body, so there are a lot of different cases. We're not going to look at a specific case of that, though. So the advantage of this one right here, this third route, that this is incredibly fast, the fastest mode to signal. And just like the other pathways in here, it can alter the permeability of the cell to ions, so it can make sodium come in, chloride come in, potassium go out as we open these channels for these ions. But what we're going to talk about today is how that third signaling pathway, opening of ion channels, can change the distribution of charge inside versus outside the cell. It can make the inside of the cell more positive, or it might make it more negative. Because if ions start coming in and out of the cell, since ions have a charge, that's going to make the inside of the cell more positive or more negative. Agreed? You guys doing alright today?
Yeah.
Weekend was okay? Hungover?
I'm tired when I go off and I go at 4 in the morning.
What time do you usually wake up?
Like 8:30.
Are you able to go back to sleep? Do you guys agree with that very last statement? ICF, ECF, more positive, more negative. So we're going to talk about that today. Activating cells by changing the charge inside versus outside. So I just drew